Yes, students. Till now, we have studied different elements of symmetries and operations about them. First one was identity, operation was identity. Second one, proper axis of rotation, operation was rotation. Third one, plane of symmetry, operation was reflection. Fourth one, center of inversion, operation was inversion. And fifth one, improper axis of rotation, operation, roto reflection. If we consider any molecule, then that molecule will be with a set of elements, set of operations. In true sense, actions are more important for us, operations are more important for us from collection point of view. If we collect the all operations possible on any molecule, then a different student will be with different answers. In order to have uniformity, some sequence we need to decide. So what is the sequence? What is the proper way of arrangement of these operations? That we are going to study today. Now, first point. Whatever the group may be, whatever the molecule may be, first operation ever we represent, that is identity. Now question will be with why? Because this is a one trivial operation, basic fundamental operation, which we can achieve by any other element. Then in spite of repeating it every time, it is better to mention first time. Once we mention it first time, next time we will not consider it. Means if I consider identity now, then around axis CNN operation which is equal to identity, that we will not consider. So first rule is represent identity first. Secondly, represent axis of symmetry. In the axis of symmetry, first proper axis of symmetry. If proper axis of symmetry, many axes are there. In such cases, what to do? The axis which has highest order, means principal axis we need to represent first, and then other axis we need to represent. One more thing is there, pay attention. If there remain coinciding axis, then after that axis, say principal axis, those coinciding axes also we need to represent. I make this rule clear by means of one example. If we consider benzene as a molecule, benzene has C6 as a principal axis. So if we consider only C6, then how many total possible operations should be there around C6? 5 operations, n-1 operations. But all are not purely C6 category. They are coincided by means of other axes. They are merged by means of other axes. They are overlapped by means of other axes. Means C6-1, rotation by simple 60 degree. It is unique operation of C6. I have to consider. C6-2, rotation by 120 degree, means equivalent to C3-1. So it is coincided by means of C3 axis. C6-3, rotation by 180 degree, it is coincided by C2 axis, C2-1 operation. C6-4, rotation by 240 degree, it means C3 operation 2 times, means it is coincided by means of the C3 axis. C6-5 means rotation by 300 degree, yes, it is a unique operation of C6. So about C6, I am getting 2 operations of purely C6 category, 2 operations of C3 category, and 1 operation of C2 category. Then while representing, first represent the operations possible by C6 category, then represent lower order coinciding axis C3, then further lower order coinciding axis C2, then other axes whichever are possible in that molecule. If I have to talk about benzene, then C2 and C2 dash, total number of operations, those we can represent. So what is our second rule? After identity, represent proper axis of rotations in decreasing order of their order. If any coinciding axis is there, then that is to mention after that axis. Operations of coinciding axis are to mention after the operations of that particular axis, main axis. Is the second rule clear? And third rule, actually we should represent the improper axis of rotation because these are the other kind of axis. But in improper kind of axis, giant kind of operations are there. Large kinds of operations are possible. If I have to start from S2, then S2 means what? Center of inversion. So if center of inversion remain present, then I should represent it by I. There S2 will not come. But it is similar to S2 operation. So I is to represent after proper axis of rotation. So what is our third rule? After proper axis of rotation, represent center of inversion or operation of inversion if it is there. Next rule, we have to represent improper axis of rotations. But here exception is there. If improper axis of rotation, main improper axis of rotation, which has the order same to the principal axis of rotation, if it is odd in number, then that can generate horizontal plane. And horizontal plane has its right to come there. We need to represent it separately as like we represent identity, as like we represent coinciding axis separately. So here horizontal plane will come first, then the operations of improper axis of rotations will be there. But if order of that improper axis of rotation is even, then horizontal plane will not come. So improper axis of rotation, then last portion, that is the planes of symmetry will be there. I tell you this rule shortly. Rule number 4 says we need to represent improper axis of rotation in increasing order of their order. But if improper axis of rotation, main improper axis of rotation is with odd order, then horizontal plane is to represent first, then improper axis of rotation. If it is even order, then improper axis of rotation in increasing order, then plane of symmetry will come. To make this concept clear, I give you one example. Say BF3 molecule. In BF3 molecule, S3 is an improper axis of rotation present. S31 is a unique operation of improper axis of rotation. S32 means axis of symmetry, that is a C32, that already we have considered. S33, yes, S33 means sigma h, horizontal plane here, in case of BF3 molecule. Then what we need to do? We need to give due respect. We need to give the right of horizontal plane. And horizontal plane we will represent first. Then operations of S3. Which operations of S3 will be there? S34 means again it is like C34 or C31 means that we have considered already. S35, yes, it is unique. And S36 means identity. So two operations of S3 will come after horizontal plane. If this improper axis of rotation is of even order means S4 or S6, then horizontal plane will not come there. Horizontal plane will come later on. Means for example, say if I consider S4, then S41 unique operation of improper axis of rotation. S42 means axis of rotation. S43 means again unique operation of improper axis of rotation. S44 means identity. Here plane has not entered. Here plane has not came. Horizontal plane has not came. Therefore, in case of even order of improper axis of rotation, horizontal plane will not be there. Is that rule number 4 clear? Now rule number 5. We need to represent all planes of symmetry. And while representing planes of symmetry, the sequence is first horizontal plane, then vertical plane, then dihedral plane. If horizontal plane is already represented, then do not represent vertical and dihedral planes. This is a way of arrangement of all operations. So these rules you need to consider. We are going to apply these rules for various point groups, and there this concept will be the more clear. In your syllabus, cyclic kind of 3-point groups are there. Dihedral kind of 1-point group is there. And linear, higher symmetry point group 2 are there. Then what are the types of the point groups? Point groups are of the 4 types. The The first, cyclic. Second, dihedral. Third, linear or higher order. And fourth, cubic or a special kind of the point group. Out of that, only 3 kinds of the point groups are included in your syllabus. Cyclic, dihedral, and in that dihedral plane is excluded. Linear or higher order. For cyclic, 3 examples are there. For dihedral, 1 example is there. And for linear, 2 examples are there. Whatever the rules we have studied, those are applicable for those point groups other than possessing dihedral plane of symmetry or cubic kind of the point groups. So for our syllabus, those rules will do. But for linear molecules, for linear point groups, higher order point groups, some additional things are there. Means those are really important from mathematical point of view. Those are really important from proper understanding point of view. Whatever we said is a general one. But now what particularly mathematical point of view, which things are there, let me explain them first. Total whatever the angular measurement is there, we are measuring up to 360 degree, means up to 2 pi. In true sense, a measurement up to pi is sufficient for us. How that I tell to you. Total 360 degree we can divide in 4 quadrants. Means from your point of view, if I have to talk, first quadrant 0 to 90 degree, second quadrant 90 to 180 degree, third quadrant 180 degree to 270 degree, fourth quadrant 270 degree to 360 degree. So what we consider 0, pi by 2, pi, 3 pi by 2, and again we can come to 2 pi. 2 pi means 360 degree. If I have to measure say 60 degree, then what we can do, from 0 to you can say 60 degree. If 120 degree, then okay, you can measure 120 degree. If 240 degree, then 240 degree means this is a way, this is a measurement. This is a one way of measurement where 240 degree large angle is coming. Or other way of measurement, from this side you can measure. You will get inverse of 120 degree. 240 degree means inverse of 120 degree. Opposite direction you have to move 120 degree. So if you have to measure any angle, no, so measurement up to pi are sufficient. Therefore, the variable angles will be considered up to pi only. So variation will be considered from 0 to pi. Especially in linear point group, C infinity as axis present. And C infinity means what? It is a rotation by very small angle also will do. Very, very small angle. Infinitesimally small angle. And that can generate from 0 degree to 360 degree. But if we see now the mathematical application, 0 degree to pi is all sufficient. Suppose if this were to explain, then inverse of that. In a group, if any element, any object, any operation remain present, then its inverse also should be there. So in spite of continuing our direction of measurement, what we do? We measure from other side. Other side means that I tell to you. And what is the need of that? See, if I show you this kind of the rotation, pay attention. This kind of rotation. What do you think? It is clockwise or anti-clockwise? Yes, from your point of view it is clockwise. But from my point of view, it is anti-clockwise. So it's the same rotation if I remain in continuation. Then I can complete the 360 degree. Now I want to measure any kind of the angle. But angle of measurement, direction of measurement, I am not supposed to change. Direction of measurement I am saying. Direction means clockwise or anti-clockwise. Anti-clockwise measurement is positive. And clockwise measurement is negative. So if I have to measure from this 0 to pi, okay, this anti-clockwise. And if I have to measure this angle, but in anti-clockwise direction, then what I need to do? I need to change my position. I need to come to your side. So if I come to your side, then 0 to pi. Anti-clockwise direction. Direction is anti-clockwise. What the second results are there is a replication of what the first result. So direction of measurement we are not changing. Angle positive only we are measuring. Only position we are changing. or from this side and the other side, a simple way that I was saying. So angle not necessarily more than pi. Up to pi it is what the more than sufficient. So C infinity, how we are representing? C infinity is a measurement of variation of a small angle, say phi. Phi is a variant that we are considering. With the help of phi we are varying more degree, more degree, more degree, more degree. So variation of phi can be up to pi. Whether exactly it is up to pi or not, that we are discussing. And double of that, a second portion, lower portion of the all quadrants can be what the covered. Lower portion of the quadrants means third and fourth quadrant can be covered. Means what? See, infinite C infinity operation that we were representing, no, that we can represent as, see here the representation, 2 C infinity and phi. Phi is a variant, and that phi angle is more than 0 degree and less than 180 degree. Now, if we would have considered 180 degree or pi, you would have understood. But why are we not considering that pi? Why are we not considering 0? That I tell to you. See, rotation by 0 degree means identity. Already we have considered. Therefore, we are not considering 0. Therefore, what is the representation for phi? Phi is more than 0. And what about pi? Rotation by 180 degree. We could have considered that. But what we are doing here? Duplication. Doubling we are doing. And when we double, then this will be doubly measured. And in order not to have double measurement, we will take it separately. We will measure it separately. So this pi is not measured there in C infinity. Separately C2. C2 means rotation by 180 degree. Means pi. Consider. So double C infinity, phi is what the variation, and one of the coinciding axis you can say that the C2 is represented. Not only for H2 molecule, for HCl molecule also, if you go through the standard books, you will find that in character table C2 as a operation. And that C2 not resulted because of the substitutory C2 axis as are there in hydrogen molecule. That axis is due to C infinity axis. That axis is brought from what the C infinity because of our definition of phi, and it is a need. Therefore, we are taking the variation of phi more than 0 and less than pi. Are you getting this point? Okay. So C infinity represented, C2 represented, accordingly S infinity axis are represented so that all operations can be covered. Now pay attention towards the sigma v, vertical planes. Infinite number of vertical planes are there, but what is the variation? Variation through per phi. Angle is not phi here, it is per phi. Per phi means variation from 0. From 0, previously it was not 0. From 0 to less than pi. Means 0 to 179.9999 degree you can consider. Now question you will be with, why here 0 is considered? If we consider 0 or the plane passing through that angle, original xy plane, then we can get indistinguishable structure. So that is resulting as indistinguishable structure. It is not equal to identity. Therefore we need to consider that. Then why not 180? See the plane we are considering, no? So you cut it by angle 0 or by 180 degree. Any of the plane is same. Therefore result will be the duplication, result will be the repetition. Repetition not allowed. Therefore pi is not considered in case of per phi. Are you getting this representation? So for hydrogen molecule, what are the representation? 2 means double quantity of C infinity operations, variations by phi, plus C2, plus infinite number of C2 operations are there. Those axes are perpendicular and those are infinite axes, and on each axis there is only one operation, plus center of inversion, plus horizontal plane, plus S infinity, improper axis of rotation, as are there proper axis of rotation, likewise improper axis of rotation. How many? Infinite. And what is the variation? Phi. But how to represent that? 2s infinity phi. And what about the plane? Vertical plane? Per phi. Infinite number of vertical planes are there with variation of per phi angle. What is per phi angle? 0 degree to less than pi. What is phi angle? Not 0 degree. More than 0 degree and less than pi. It was an attempt to explain the terminologies used in linear point groups, means C infinity V or D infinity H. By the way, our main point is understanding the sequence of arrangement of various operations. What are the rules I told to you? Those are applicable to cyclic and dihedral point group, except the point group possessing dihedral plane. And for linear molecules, for cubic molecules, separate kinds of rules are there. But time being, for linear molecules, we are going to follow the rules which we have learned. Which rules have we learned? First, identity. Second, proper axis of rotation in the decreasing order. And coinciding axis will follow that particular axis. Then center of inversion. Then horizontal plane if improper axis of odd ordered. Then improper axis of rotation. Then planes. Sequence of planes if horizontal plane previously not represented, then horizontal, vertical and dihedral. So this is the point I need to inform to you. With various examples, I tried to explain those things. And students, this will be more clear if you study more, if you learn more point groups, if you go through the various examples. Now I give the homework. Take one molecule, say BF3 molecule. Then find out all possible operations I am saying, all possible operations, and arrange them as per the rules those I told to you. And addition to that, mention order of that point group. Order of the point group means total number of operations. H, it is represented as H. Point group remains with order. I repeat, what is the homework? For BF3 molecule, arrange all possible operations as per the sequence that I told to you. And mention order of the group. What is order? H means number of total operations in that group. The name of the group, everything that we will see from next lecture. Different point groups we will discuss.